So let's now get into this project. So the objective, as mentioned in the introduction, to develop a deep learning model on blood spectroscopy data to predict low, okay, or high levels of LDL cholesterol. So we're not just focusing on predicting high levels, but actually predicting all three classes of LDL cholesterol. We have a dataset of 29,160 samples taken from 486 individuals with a wavelength range between 950 nanometers and 1,350 nanometers. The libraries that we use are pandas for data manipulation, Seaborn for data visualization, and same with matplotlib, NumPy for numerical computing, scikit-learn, which is a machine learning library, which we use mainly for preprocessing, ImbalanceLearn to deal with imbalanced data, TensorFlow, which is the main library for actually building the architecture of our deep learning model, Optuna for optimizing our model, and lastly SHAP to interpret our model. The first step here is actually importing these libraries in our code, and here I've imported them all. So it's important that you run this so that any functions that we use from these libraries can be recognized. We then do some brief data exploration, first by using the read CSV function and reading in the CSV file, storing it under the variable name df. This enables us to look into our data frame. So when we use df.head, we can see the first few rows of our data, and here we can see the different absorbance values. We can think of these as different wavelengths and how much light has been absorbed. So we can see all the absorbance values. We also have temperature and humidity, which are recorded at the time of blood spectroscopy. We're also given the HDL level of cholesterol, the hemoglobin levels, and also the LDL cholesterol, which is the focus for this project. So for the first step, we look at the distribution of our LDL cholesterol levels. So how many have high LDL cholesterol, how many have okay, and how many have low. So for that, we can use the Seaborn library, the count plot, and if we run this code here, so just as your information, to run the code, just press the play button here on the left, and make sure that you do that for the previous blocks here. And that displays the following graph. So we can see straight away that the majority of people have okay LDL cholesterol levels, which is expected. Quite a few have high, and a few have low. So this raises a red flag. If we were to build a model on this data as it is, the model will specialize towards predicting okay and high levels of LDL cholesterol because it has more examples to train on to predict these two labels. There is a way we can deal with that, which is a method called oversampling, and there is a link here that explains how that works. We use a particular method of oversampling called SMOTE. I won't go into too much detail, but essentially it produces synthetic data so that our classes become balanced and a model becomes less biased towards predicting a certain class.